Okay, I think I am ready. Welcome everyone. My name is Adrian. I am AI software evangelist at Intel, and today I would like to prove you that you no longer need cloud to run large language models, and you can run it on this computer here. And I will do live demo in 3 slides, so please bear with me. And of course, let's start with the challenge. Why do we need to deploy, right? Because of course, training the model is only half of the way. We train for something. We try and train the model, or we use the pre-trained model to then deploy it and use it in the production, right? And what are the options, right? For the deployment, we of course can use the cloud, our own cloud or any other external API when we have limitless computing on demand, right? But at the same time, we risk data privacy, we depend on the internet connection. We can expect high latency, especially if the internet connection is not perfect. And we have also unpredictable costs. So there is also one more way to deploy AI models, especially LLMs. We can use AAPC, a local API, local computer for that. And we have, of course, data sovereignty, cost efficiency, increased control, optimal consumption of the energy, special computing capabilities. But at the same time, there is no free lunch, right? We have limited computing resources. And the question is, if they are as limited as we think. And I prepared a demo to run the language models on my laptop right now, and I will do that in front of you. So one moment. What I did, I started this demo. It's running locally on my computer. You can see localhost here, right? Then, of course, in this speech, I will explain what I'm doing. But right now, I would like to show you something. I'm using the Qwen 3 model, 8 billion. So I'm super happy that Greg just mentioned that on the previous speech. And because the model is thinking, and I'm not a very fan of this thinking mode. I'm just putting no think, right? So we will see the results all the time. So let me ask, what are the deployment options for LLMs? And you will see right now the response. And to prove that I am not connecting to any cloud, I will open that and I will show you my GPU. And this GPU, what's funny, it's an integrated GPU. There is no discrete GPU card. As you can see, it's Intel Arc 140V, which is part of your CPU. So I'm not using any discrete GPU card, and I'm not using any internet solution. As you can see, we are getting quite good response, right? I mean, the performance at least. Of course, it's not as fast as it would be when you use ChatGPT or so. But the question is, do you need running faster? Probably for most cases, it's absolutely enough, right? Okay, so let's wait for it before it finishes, so then we can switch to the other model. This model was compiled to use the integrated GPU, but this is not only what I have here. So what I have, let me open Task Manager again. You will see that we have a CPU together with iGPU and NPU, which is Neural Processing Unit. And all of these devices are on the same chip. This chip I am presenting to you right now, right? That small device, that one is even with the memory, is capable to run all the LLMs you can see here on the screen. Good. Now let me switch. Of course, I'm not judging the accuracy of the answer, right? The model is not my model, right? It's a Qwen 3. It's an open source model, so I just took it from the internet. So right now I'm switching to the second model. Maybe I will start a new conversation. I will ask about the same. I'm switching to the second model. That one is exactly the same model, but compiled for NPU. So right now I will use the NPU, and I would like to use the same mode. So no think. Do I typing? Yes. No think. And what are the options for LLM deployment? Okay, let's see. No, nothing is working right now. NPU is empty. GPU should be also not computing anything, right? Good, sending one more request to NPU, and we are getting the response. And right now, we can see that we are using the NPU. The performance is similar, right? So we can see that it's quite good, I would say, at least more than 10 tokens per second. And why we say that 10 tokens per second is a good threshold? Because people read, in average, 10 tokens per second, right? So everything which is faster is a good user experience, usually. And we can see that we are running on the NPU. And so why do we have two different devices we can run on? Of course, we can even run on CPU, right? But it will be a little bit slower because CPU is not designed to run the inference of the AI. GPU is, of course, it was created for the graphics and so on, and NPU is specifically designed for neural network inference because it's good for matrix multiplication. And that's why NPU is good for that. And at the same time, it takes a little bit less power. So if we look at the power usage for the GPU, when it was, we don't have that history already, we can see that right now we are using about 20 watts running on NPU. And if we use GPU, it will be like 5 watts more or something, right? So yeah, I don't have that data here right now. I would run it again, so you will see that. So maybe let's try going back to the previous one. So it was 20 when we used NPU. Right now in the idle state, it's 5, 6 watts. And when we use GPU, let's say, again, no thing, high or whatever, right? Because I don't want a long answer. We will see that it's running on GPU. Again, oh, it was super fast, so too fast. OK, let's click this. And then let's see the performance and the power usage. So right now it's 26, 27, right? So if we compare to the 7 or 6 in the idle state, then inference on NPU 13 watts more, and on GPU 20 watts more, right? So it's about, NPU takes 60% of the GPU power, something like that, and power usage, right? So this is good, especially if we care about the battery of the devices, for example. So that's why NPU is good for that kind of applications. But of course, GPU, integrated GPU, you can use as well. Good, let's back to the deck then, and then I will tell you what I did to achieve that result. Good. So training, this is just 50% of the work done. The second half is, of course, the right hardware and the right software. So optimization is super important. So the solution, what I did? Well, I used the Intel Core Ultra here with 3 different devices, what I already said. CPU, good for fast response. GPU for high throughput, and NPU for power efficiency, right? And I presented already running on GPU and NPU. Then what I need also to have enough memory because we are running 8B model, right? So we need to have floating at least 32 gigabytes in floating point 32. Yes, that's true. We use the quantization. I will talk a little bit later about that. So we didn't have to have 32. And what we had, it was 28 gigabytes. And how is it possible, right? Usually, iGPU have only half of the memory, of the system memory. So if I have 32 gigabytes in this computer, I would be able to use only 16 gigabytes. Well, that was true in the past, but right now, you can change that behavior in the latest driver. You can change how much memory is dedicated to your integrated GPU and NPU, and you can increase that up to 87%. And I really recommend doing that, especially if you do some AI, because you would need that memory. So this is the right hardware. Then let's talk about the right software. What I used, it was OpenVINO model server. This is part of our OpenVINO toolkit. I will let you know in a moment about that. But OpenVINO model server is a solution to serve the models, right? To bring you some API that you can hit with your application, and you can get some response, right? So, for example, you can send the banana image and you can get the prediction. This is banana. It's a simple image classification case. But of course, you can do the same with the language models. You can send the question or comment and you can get the response with this streaming mode as well. And how to use OpenVINO model server? What you need to do in Docker, you just download the model using this command, and it was Qwen 3.8b in 4, as I mentioned already. Then you add the model to the config file, and then you run Docker with OVMS, OpenVINO model server, and that's it. For Windows, it's a little bit more difficult because what I know that Docker is not the best solution for Windows and doesn't work well. So what we provide here is a executable OVMS when you do exactly the same. You download the model, you add it to the config, and you run the OVMS. But this is the high level, right? High level of serving models. But how it runs the inference inside, right? We know the hardware already, but the software part is that it uses OpenVINO. And OpenVINO is our solution, and it's open source solution for optimizing and deploying AI inference. It started in 2018 as Open Visual Inference and Neural Network Optimization, but that was only at the beginning, right? Right now it supports any kind of AI inference, audio, language models, GenAI, transformers, whatever, right? And as I mentioned, it's super important that it's open source, so we can use in any kind of application, even commercial ones. And it's, of course, licensed under Apache 2.0. So how to use it? Well, you can use any of these frameworks. You have your model in, like PyTorch, TensorFlow, Keras, ONNX, or whatever. Then you convert the model to the OpenVINO format, and you are able to run on variety of Intel hardware, like CPUs, integrated GPUs, but also discrete GPUs from Intel, NPUs, and FPGA. And of course, it runs on any operating system, Windows, Linux, or Mac. But OpenVINO is like a toolkit, right? But what we specifically use for the GenAI for language models is OpenVINO GenAI package. And we have different pipelines here for text generation, for RAG pipelines. We have LLM pipeline, text embedding, text re-ranking. But also we support image generation, which I didn't show today, but it's possible. Visual language models, speech generation, video transcription, translation. And what you need to do is just provide the model to the pipeline and, of course, use it in the AI app. And because we used OVMS, you don't need to, use OpenVINO GenAI directly. I'm just saying that OpenVINO model server under the hood uses OpenVINO GenAI. Where to find the model? I used like Qwen 3, which was already quantized and pre-optimized and everything like that. Well, we have our own account on Hugging Face when you can look for OpenVINO pre-optimized and pre-converted models. And you can just download it using the Hugging Face or as we did with the OVMS. But even if the model is not already pre-optimized by us because of the licensing problems or something, right? Llama 3, we cannot provide you pre-optimized Llama 3 because you need to accept the license. So what you need to do, you can do it yourself with the Optimum Intel. So you use just Optimum Intel to convert the model yourself. The support for the model is already implemented. We cannot just do it for you. And what we support, I already told you that text generation, image models, speech transcription, translation, specific models, not all of them. The most important are listed here, like Llama, Mistral, Phi, Qwen, ChatGLM, DeepSeek, Falcon, Gemma, and so on. For image generation, it's LCM, Stable Diffusion, Flux, speech transcription by Whisper, Distal Whisper, image processing via VLMs, Lava, Mini, CPMV, Phi, QuenVL, and so on. For speech generation, for now, we support only SpeechT5, and for embedding and re-ranking, all the models from BERT, Roberta, Qwen, and so on. And if we look at the code, how easy or difficult it is to run this pipeline, right? It's just 3 lines of code. Of course, everything was done for you here through the OVMS, right? But if you are interested to doing yourself because you would like to have more control or something and you don't want to expose API, you just would like to do it yourself in the code, just 3 lines of code, right? Import OpenVINO GenAI, create the pipeline when you specify the model path and the device you would like to run on, and you run the inference with pipe generate function. So that was how we ran the inference. However, I mentioned that the model was already pre-optimized, and what we did to deliver a very nice performance, well, we did some quantization. Maybe you heard about that already. It's quite a popular topic nowadays. So we call it weight compression because it wasn't the full post-training quantization. It was just compressing all the weights to int4 or int8, depending on the specific layer. And it works like that. When you have the trained model, which is still in the floating point 32, then you use the algorithm for the weight compression, changing all the weights to the int8, int4, and then you have the quantized model. And how to do that? Well, you need to use some kind of the software for that. For example, Python package, which is called Neural Network Compression Framework. This is also part of OpenVINO toolkit. So you have your model, which is like full model still with floating point 32. We support different frameworks like PyTorch, TensorFlow, ONNX, or OpenVINO. So you can even quantize your PyTorch models if you want. And you can use any of these techniques, and then you end up with some compressed model somehow, right? For example, in a different precision. How to use it? Pip install NNCF, and then, of course, use the NNCF API. I will show a few lines of code on this slide. So int8 quantization, for example, in Python code, you use the OpenVINO model for casual LLM class when you, and the function which is called from pretrained, and then you specify quantization config that bits equals 8. It means that the model will be quantized, the weights of the model will be quantized to int8. For int4, you specify bits equals 4, but at the same time, you need to specify ratio. It doesn't make sense to convert 100% all the layers to int4, otherwise you will lose a lot of quality of the model. So int4 is a very, very compressed format, and you still should have about 20% of the layers in at least int8. Otherwise, you will really lose the accuracy. And which layers should be still in the int8? Which of them should be quantized to int4? Well, you don't have to worry about that. We have the algorithm to detect which layers are sensitive for quantization, and we preserve them in int8. And the other layers which are not sensitive, they are quantized to int4. You can also do the data-aware weight quantization when you provide some additional data set. It gives us better understanding while we're quantizing about the value range between different layers, so we can quantize it even better. And there is also hybrid quantization, especially for stable diffusion pipelines, so not specifically here for LLMs. You can do the same, of course, in the command line. Use just Optimum CLI, specify exactly the same parameters like int8 or int4 with the ratio of 0.8. For data-aware quantization, additional flags like AVQ and dataset, and for hybrid quantization like this. And then you will end up with that kind of graph when you have an activations in floating point 32, but your weights are quantized to int4, int8, and while doing the inference, they must be decompressed, dequantized to floating point 32, right? So all the operations or the calculation are still in the floating point, but the data for the weights are stored in integer. It's still very good thing, I would say, because when we look at this table, and I know that these models are quite old, right? But it's exactly the same for the newer models. When you look, for example, at Llama 2, which is in the middle, and floating point 32, the perplexity is 3.28, right? Perplexity means like how bad your model is. The higher, the worse. And then when you quantize that model to int8, and we are talking about weight quantization only, your perplexity increases by just 0.01. It's like negligible thing. And at the same time, you are decreasing the model size from 25 gigabytes to 6.3, which is super nice. And of course, we can go further because we do that, and we go into int4 with the asymmetric quantization. That's why we say we have asym here. Group size 128 and ratio 80%. And our perplexity, of course, increases to 3.41. But at the same time, our model size decreases more to 4 gigabytes only. And you know what? This is important when you save some space on the disk, or you save some bandwidth when you download the model from the internet. But what's even more, it's super important because you also save RAM usage. because you need to use just 4 bits per weight in your RAM. And you know how RAM is expensive right now, right? So quantization is super a nice thing. So once again, 50% for training and the other 50% for the right hardware and the right software. And don't just believe me. This is open source demo I presented. This is the QR code. You can go to our GitHub. You can see the demo. You can install it on your computer. It should be really straightforward. I just followed the instructions. And you can try yourself, and you can see maybe some of the language models can run directly, locally on your computer, and you are fully sure that all the data stays with you. And I can see still people are still taking photos, so no worries. We still have time. Good. And that's what I wanted to talk about today. Thank you very much, and I hope you will try it later.
All right, so we can ask the questions now. Anyone got any? Right.
Yes, I can go back, yes.
Right, thanks. A great practical test, loved it. Does it work on NVIDIA? That's my question.
OpenVINO doesn't support NVIDIA officially. Yes, I'm
Please
sorry.
support it. It'll be faster.
Yeah, I know. They have their own solution, TensorRT. We have our own, yes.
Okay, I see. Thank you.
Yes.
Anyone else? All right, thank you very much. And now we are heading into a 30-minute break.
Yeah, thanks.
Thank you.